Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
So as on your screen it is present a reaction which is already unbalanced, but it is sure that it is a redox reaction, and now we are going to balance it. But this will require a series of steps, and what are those series? Let us see one by one and evaluate what would be the balanced reaction of the overall given equation. So let us see. I would consider it as naming step number 1. I'll name it as determination of oxidation number. So what do we do in this step? We evaluate or we determine the oxidation number of the atom present in a molecule for the both reactant molecules as well as for the product molecules. So in this case, we are going to determine the oxidation number of the first reactant which is present, that is MnO4 minus. So in this case, we know that the oxidation number of oxygen is easily known, that is it is -2. But the oxidation state of manganese is not known to us. So what we'll do is we'll calculate or we'll determine the oxidation number of manganese in this reactant. So therefore, how can we write this? The oxidation number of MnO4 minus is 1 minus. As you can see, the whole molecule consists of a charge of -1. So I could write it as 1 minus. So therefore, I can evaluate this thing as 1 into Mn plus 4 times that of oxygen. I am writing in oxy so as you should not confuse between oxygen atom and 0 because it might be very confusing. So, and the overall charge present in this is -1. So therefore, I consider the oxidation number of manganese to be X, which I don't know right now. So therefore, 4 into the oxidation number of oxygen, which is 2 minus, is equals to -1. Therefore, X is equals to -1. This is -8. 4 into -2, that is -8. This -8 will go over there and it will become +8. So therefore, the oxidation number of manganese, therefore the oxidation number of manganese in MnO4 minus is 7 plus. So this is for the first reactant and not. And now what we are going to do is we are going to calculate or we are going to determine the oxidation number of the second reactant, which is nothing but SO3 2 minus. So in this case, we know the oxidation number of oxygen, but we don't know the oxidation number of sulfur because the oxidation number of sulfur varies with respect to its atoms attached in a molecule. So now we are going to calculate the oxidation number of sulfur. So how can we calculate? First of all, we could write the oxidation number of SO3 2 minus is -2. Therefore, this can be written as 1 into S plus 3 into oxy, and the overall charge present in this molecule is 2 minus. I could write it as -2. So therefore, I consider the oxidation state of sulfur in this case, because previously also we have taken the value of the manganese as X, but in this case we are also taking it as X, and we will not relate this X with the previous one. We are making sure that this value of X is just for sulfur in this case. So therefore 1 into X is nothing but X itself. So 3 into overall charge is -2 for oxygen, and in this case the overall charge of the molecule is -2. So therefore X is nothing but -2. 3 into -2 is 6. So if 6 goes there, -6 goes there, then it will become plus 6. So therefore the value of X in this case is 4. Therefore the oxidation number or oxidation state, the both are same, of sulfur in SO3 2 minus is 4 plus. So this is how we have calculated the oxidation number of sulfur. And this plays a very important role to balance the reaction, how we will see. But the oxidation number of the products are also remaining. So now we are going to determine the oxidation number of products also. So in this case, the first product that we have got or is been mentioned is Mn2 plus. In this case, we don't have to determine the oxidation number of manganese because it is already been mentioned in the form of ion. The charge present on the Mn2 plus is nothing but the oxidation number itself. So therefore, the oxidation number of manganese in Mn2 plus is nothing but 2 plus. But the next product is also remaining, which is nothing but SO4 2 minus. So therefore I could write it as the oxidation number of SO4 2 minus is minus 2 or 2 minus, as we can write in that way also. So therefore 1 into sulfur plus 4 into oxy, and the overall charge is minus 2. So therefore I would consider the value of sulfur, the oxidation number of sulfur, as X in this case. So X plus 4 into minus 2, which becomes minus 2, therefore X is equals to, this is minus 2 and 4 into minus 2 is minus 8, but if this minus 8 goes over the next one on the right hand side, then we could get it as plus 8. So therefore we have got the value of X as 6. Therefore the oxidation number of sulfur in SO4 2 minus is, therefore the oxidation number of sulfur in SO4 2 minus is 6 plus. So this is how we have determined the oxidation number of the atoms. But now we are going to arrange in a very good format so that we could understand that which reactant has shown oxidation and which reactant has shown reduction process in this reaction which is given to us. So before that, I will arrange the equation as it was mentioned. So therefore the equation which was mentioned was MnO4 minus plus SO3 2 minus, that has given me Mn2 plus plus SO4 2 minus. So the oxidation number of manganese that we have calculated earlier was found to be 7 plus, and that of SO3 2 minus was found to be 4 plus, and that of Mn2 plus is nothing but 2 plus itself, and that of SO4 2 minus was found to be 6 plus. So as we can observe that the manganese, which has an oxidation number of 7 in MnO4 minus, is now being converted to an oxidation number of 2 plus in the Mn2 plus ion. So therefore this reaction which is present here, as you can see, so therefore this Mn, which has a value of oxidation number of 7 plus, is now being converted into 2 plus. So basically the oxidation number is been decreasing, and this is only possible if this reaction is shown like a reduction. So therefore this process is nothing but reduction. And the next one, that is SO3 2 minus is converted into SO4 2 minus, but the oxidation number changes from plus 4 or 4 plus 2 plus 6. In this case, the oxidation number is increasing. This is only possible if electron is being lost by the SO3 2 minus, so as we could get an oxidation process. So therefore this process is nothing but oxidation. So because of we have determined which one is showing oxidation or which one is showing reduction, so it is very clear that the overall reaction which is given to us is a redox reaction. But the reaction or the balancing thing is not yet over yet. Now what we have to do is we have to balance the electron also. So let us see how much electron has been lost by the, so this is not over yet. Now what we have to do is we have to determine the how many electrons are being lost and how many electrons are being gained in this unbalanced reaction. So the step number 1 is being over. So now we are heading towards the step number 2, which is I would mention the step number 2 as balancing the electrons. So how can we write? So first of all, let me tell you that electrons are being lost during oxidation process. So in this reaction, basically, the manganese is showing reduction. So therefore in reduction process, what will happen? Electron will be gained. So therefore I could write it as the number of electron gained during reduction process will be what? Initially, I can show you. Initially it was 7 plus. So 7 plus can be converted into 2 plus only and only if it accepts 5 electron. Because if it converts from 7 to 2 means it has accepted 5 electrons to get converted into 2. So that 5 electrons will cancel out the positive charge, that is 7 plus, and what we are left with is 2 plus charge. So therefore I could write it as the number of gain of electrons during reduction process will be 5. So the number of electron lost during oxidation will be what? So the number of electron lost during oxidation will be, let me tell you, in this case, as you can see, the oxidation number is changing from plus 4 to plus 6. So this means the number of electron lost by the plus 4 oxidation state for the sulfur is 2 electrons are being lost. So if 4 plus will lose 2 electrons, then only it will convert into 6 plus. So therefore the number of electron lost by the sulfur in SO3 2 minus will be 2. So therefore I could write it as the number of electron lost during oxidation is 2. But as we can see, the number of electron lost and the number of electrons gained are not same, because as we can see it is 5 while it is 2. So we have to balance this electron, and that's why I have named the step as balancing electron. So this will be only balanced if I multiply the reduction process by 2 and multiply the oxidation process by 5. So the equation that we have initially was MnO4 minus plus SO3 2 minus, that has given Mn2 plus plus SO4 2 minus. So now what we are going to do is we are going to multiply 2 for the one which is showing a reduction process. So in this case, what we are going to do is now we are going to multiply 2 with the one who is showing reduction process, that is this one. We are multiplying 2 with MnO4 minus, and if Mn is repeating twice, then this product will also repeat twice. And later what we can do is we have to multiply by phi for the one who is showing oxidation process. In this case the oxidation is shown by SO4, sorry, the oxidation is shown by SO3 2 minus. So therefore we have to multiply this by phi, and if sulfur is repeating 5 times, then for the product also the sulfur will repeat 5 times. So we are going to multiply with the oxidation process as well as for the reduction process. So let us see what will be the equation that we will get after multiplication. So we will get the new equation as we'll get the new equation as 2 into MnO4 minus plus 5 into SO3 2 minus. That should give us, again Mn is repeating twice, so therefore I would write it 2 times Mn2 plus, because I am multiplying the oxidation as into 5, so therefore the answer that I could get for this reaction is 5SO4 2 minus. So this is what we have calculated. So this is how we have calculated the electron number of electron, and we have balanced it electronically. So this was the second step that we have did, but the step number next is also remaining. There are many number of steps that we are going to do so as to balance the overall reaction. So let us move to the next step. So but we have to remember that our recent reaction which is balanced electronically is this one, not the earlier one. So we have to consider this reaction itself, and we'll head forward by help of this reaction only. So the next step would be step number 3. And in step number 3 what we are going to do is we are going to look out how many number of atoms of oxygen are present on the left side, that is on the reactant side, and how many number of oxygen which are present on the right hand side. So let us find it out. So I will name this as step number 3 as balancing oxygen atoms. So as we can see the latest equation or the recent equation. So now let us see how many number of oxygen atoms are present on the reactant side and how many number of oxygen are present on the right hand side. So this was the recent equation that we have balanced, which was 2 times MnO4 minus plus 5 times SO3 2 minus. That should give us 2 times Mn2 plus 5 moles of SO4 2 minus. So in this case, if I calculate the number of oxygen atom present on the reactant side, I could get this is 4 times MnO4. So oxygen is 4 times in MnO4. But if I'll multiply by 2 moles, then I would get it as number of oxygen atom as 8, just in the 2 moles of MnO4. But there are 5 moles of SO3 2 minus. So therefore SO3 has 3 oxygen, while the 5 moles of SO3 will have, making a total of 15 oxygen. So what we can do is we could write it in this way: the number of oxygen atoms on left hand side, or basically the reactants, is nothing but what we have initially we have got as 8 plus 15. So this make us to write in a way to give 23 atoms of oxygen which is present on the left hand side. So let us now calculate the number of oxygen which is present on the right hand side or in the product. So the number of oxygen present on the product side is, for SO4 it is 4 itself, but since the SO4 is repeating 5 times, or there are 5 moles of SO4 2 minus, so it makes an overall oxygen atom content as 20. So we could write it as the number of oxygen atoms on right hand side is 20. But we should notice that the number of oxygen which is present on left hand side, which is 23, and the number of oxygen present on the right hand side is 20. So the equation is not balanced with oxygen. So what we are going to do is we are now going to balance the oxygen right now. So as we can see, there is a deficiency of oxygen present on the right hand side or present in the product. So what we are going to do, we will add oxygen in the means of adding water. You might be thinking why we are adding water, because water is an neutral compound which is acid as well as which is base, which means it is behaving as an amphoteric compound. You might be thinking why we are adding water, because water is a neutral compound and it acts as like a base also as well as like a acid also. So we will add water molecules, but one water molecule consists of only one oxygen atom. So because there are 3 oxygen atom deficient in the right hand side or deficient in the product side, so we'll add 3 times that of H2O molecules. So therefore, since 3 oxygen atoms are less in products, therefore we will add 3 times H2O on right hand side reaction. So the answer that we could get is, initially let me tell you, the second step reaction was 2 times MnO4 minus plus 5 times SO32 minus, that gives us 2 times Mn2 plus 5 times SO42 minus. So what we are now going to do is we are going to add water molecule which is deficient in the product side. So we are going to add 3 moles of water in this reaction only. So what we'll get? So we will get 2 times MnO4 minus, that should give us, that is reacted with 5 times SO32 minus, which gives us 2 times Mn2 plus 5 times SO42 minus. But recently we have equated that we should add 3 moles of H2O. So therefore we are now making 3 moles of H2O as an addition in the product. And now the oxygen is been balanced in the reactant as well as in the product side. But as we have added water in it, so the number of content of hydrogen has been increased. So how can we balance that? So that's why we have included a next step, and that step is step number 4. And I have named the step number 4 as addition of hydrogen, or I could say it as balancing hydrogen atoms. So therefore the step number 4 will be balancing hydrogen atoms. And now what we are going to do is, again for balancing we will measure or will calculate the number of hydrogen present on the left hand side and the number of hydrogen which is present on the right hand side. So the number of hydrogen present on left hand side, that is on the reactant side, is nothing but 0. While the number of hydrogen atoms present on RHS, or basically present on the product side, is 2 for H2O, but there are 3 moles of H2O, which makes an overall 6 hydrogen atoms present in the product side. So therefore there are the number of hydrogen atoms present in the right hand side or the product side is 6. And now what we are going to do, we are now compare, now what we are going to do is, now we are going to compare the number of hydrogen atoms present in the left hand side and the number of hydrogen atom present on the right hand side. So as we can see, it is 0 and it is 6 on the right hand side. So both are not being balanced. As well as on the left hand side, there are deficiency of 6 hydrogen atoms. So therefore what we are going to do now, because we are doing an acidic medium, and acidic medium means we are writing or we are representing it with H plus. So therefore we are going to add 6 times H plus on the left hand side. So let us see what we'll get. So therefore adding 6 times H plus or 6 moles of H plus on the deficient side, that is in this case it is left hand side. So we'll get the equation as, the earlier equation that we have got was 2 times MnO4 minus plus 5 times SO3 2 minus, which has given us 2 times Mn2 plus 5 times SO4 2 minus plus 3 times H2. Now we are going to add 6 times H plus on the left hand side, which means we are going to add 6 times H plus on the reactant side. So we are taking this reaction as a consideration and will add the number of hydrogen here itself. So therefore the overall reaction that we have got is 2 times MnO4 minus plus 5 times SO3 2 minus plus 6 times of H plus, that should give us 2 times Mn2 plus 5 times of SO4 2 minus plus 3 times that of H2. So now this reaction is balanced with manganese, that is 2 times of manganese. It is balanced with electrons also, as we have earlier did, as well as it is now being balanced with oxygen atoms also, and ultimately it is being balanced with the hydrogen atoms also. And since we are doing it in acidic medium, so therefore we have represented it by H plus. So this is the overall balanced reaction that we have evaluated from an unbalanced reaction by using the oxidation number methods and various steps. So let us do it for another one. So friends, now you have got to know how you could balance an unbalanced reaction by using this concept. So thank you for watching this video. I hope you have liked this video, and please share this video with your friends and let them know too. So don't forget to subscribe Ekeeda channel. Thank you so much.